So welcome to my channel. Now we solve some question from uh, quantum mechanics which are coming in Calcutta University B.Sc course. Okay, so the questions are, first question A is given as one dimensional wave function of a particle is given as psi of x equals to root over a times e to the power iota x, where a is positive, and we have to find the probability of the finding the particle in between x equals to 1 by a to 2 by a. Okay, so first of all psi of x is given in this way. So what will be the probability? The probability will be uh, uh, integration minus infinity to plus infinity psi star psi, that is mod of psi of x whole square into dx. Okay, now we have to find the probability in between 1 by a to 2 by a. So the lower limit will be 1 by a and upper limit will be 2 by a. So after that integration, now we have to integrate these things, and after substituting this value we get this answer. Okay, so half times e to the power minus 2 minus e to the power minus 4. Okay, so this will be the answer. Now second question is given as consider a particle moving with velocity the uncertainty in the position of the particle in 2 times uncertainty in position in particle, that is delta x, will be twice of its de Broglie wavelength, that is twice of lambda. Okay, now calculate the uncertainty in measuring the velocity of the particle. That is, we have to find out p, and from del p we need to find del v. Okay, so what will be the answer of question B? So del x is given as twice of de Broglie wavelength. Now de Broglie wavelength lambda equals to h by p. This is the de Broglie hypothesis. So h by p, p is nothing but mv. Then using the uncertainty relation, that is del x del p h cross by less equals to h cross by 2, we can easily find del v in terms of del p, that is del v is in terms of del p, that is del p by m. Okay, now after substituting this value, that is del p getter equals to, from this relation, del p getter equals to h cross divided by twice into del x. So h cross is nothing but h by 2 pi. So h is 6.626 divided by 2 pi into 10 to the power minus 34. This value approx 1.055. Okay, after substituting this h value here and divided by twice into what? Twice into del x. So del x is given as in terms of this h by mv. Okay, v is given already, that is 7.28 into 10 to the power 7. Substituting this, we can easily find the del x. So del x is these things, 1.998 into 10 to the power minus 11. This is 2 times. Okay, 2 times. Then we can easily find the del p value. After finding del p, from del p we can find del v, that is del v is nothing but del p by m, where m is the mass of that particle. That is, here the particle is given as, okay, uncertainty of the particle. Consider a particle moving in a velocity. So we can consider the particle as electron. Okay, we can consider as the particle as electron, because there is okay okay there is not mention the mass of that particle. Okay, so we can consider as electron. Okay, because okay, we can consider it as electron. Okay, next question, option C. So consider a particle of 2 atomic unit mass executing harmonic oscillation in one dimension, in 1D, in the potential. This potential is given for harmonic oscillator. So V and X both are in atomic units. So what is the value of the ground state energy? Okay, so Vx is given as 4x square. So 4x square means, if we compare the general form of potential for harmonic oscillator, that is half m omega square, so therefore m omega square will be 1. Okay, so if we compare both sides, then we get 4x square equals to these things. Okay, and from here we can find omega value. Okay, omega equals to root over 8. Now we know that the energy in general for harmonic oscillator, energy is defined as En equals to n plus half times h cross omega, where n is integer including 0. Okay, positive integer obviously including 0, 0, 1, 2 and dot dot dot. Okay, so if n equals to 0, that corresponds to ground state. Okay, so what will be the ground state energy? That will be half times h cross omega. Now omega is here root over 8. Okay, root under 8. So the result will be root under h times h cross. So result will be root 2 h cross. Okay. Okay. Since here given unit mass, so here we put m equals to 1 here. Okay, so m equals to 1 here, that's why m equals to 1 here. Okay, now move to next question. So lx, ly, lz. So next question of question D given as Lx, Ly, Lz are the Cartesian component of angular momentum, and L plus, we know that L plus is called rising operator for angular momentum, Lx plus iota Ly. Then so Lx comma L plus, that is the commutation bracket of Lx L plus, will be H cross L plus. Okay, so what will be the answer? Okay, so D is given as L plus Lx plus iota Ly, and commutation, we know that the commutation relation of Lx Ly will be iota H cross Lz, and commutation of Ly Lz will be iota H cross Ly Lx, and commutation of Lz and Lx is iota H cross Ly. Okay, now we have to find out commutation of Lx Ly. So Lx Ly, L plus is Lx plus iota Ly, then Lx and Lx Ly, we get that is minus H cross Lz. Okay, so but we have to prove the commutation of Lx L plus will be H cross L plus. Okay, so so this expression is wrong. Okay, why? Because commutation of Lx L plus, we get minus H cross Lz. Okay, so if we find commutation of Lz L plus, then we get H cross L plus. Okay, so this question is wrong. So if we need to find commutation of Lx L plus, then we get minus H cross Lz. If we need to find commutation of Lz L plus, then we get H cross L plus. Okay, so this is not correct expression. Okay, this is not correct. So commutation of Lx L plus will be minus H plus Lz. Okay, since commutation of Lz we can find here. Okay, so commutation of Lz with L plus will be commutation of Lz comma Lx plus iota Ly. Therefore Lz Lx plus iota Lz Ly. Okay, then commutation of Lz Lx will be iota H cross Ly, iota H cross Ly. Okay, and commutation of Lz Ly, this is anticyclic order, so therefore it will be minus iota H cross Lx. So what we will get, that is H cross Lx plus iota H cross Ly. So H cross times Lx plus iota Ly, therefore we get H cross L plus. So this is the answer. So commutation of Lz with L plus will be H cross L plus, but commutation of Lx with L plus will be minus H cross Lz. Okay, clear? Okay, next question. Question E, given as 2 electron atom, for a 2 electron atom, L1 is given, L2 is given, then we have to find the state in LS coupling scheme. Okay, now here L1 and L2 given, that is small L1 small L2. Okay, now total orbital angular momentum L can run from mod of L1 minus L2 to mod of L1 plus L2. Okay, mod of L1 minus L2 to mod of L1 plus L2. So similarly the total spin angular momentum s also runs from mod of s1 minus s2 to mod of s1 plus s2. Okay, therefore we get corresponding this set L1 and L2 equals to 2 and 1, we get capital L is 1 2 3 and capital S is 0 and 1. Okay, for 2 electron system. Now we also need to know uh, the J value. Okay, so J is defined as L plus S. So here J value runs from L minus S mod of L minus S to mod of L plus S. Okay, now corresponding L equals to 1, S will be what, 0 and 1. Okay, so therefore J will be L minus S, that is for S equals to 0, that is L minus S, that will be J equals to 1, and for S equals to 1, J will be L minus S, that is 1 minus 1, to L plus S, that is 1 plus 1, that is 2. So the value of J will be 0 1 and 2. For in this similar way, for L equals to 2, we get J value 2 and corresponding S equals to 1 1 2 3, and similar way we need to find the value of J corresponding L equals to 3. Okay, now we know the spectroscopic notation is defined as denoted by X. This is from this comes from L value. When L equals to 0, it indicate the capital S. Okay, and L equals to 1, it indicates capital P. L equals to 2, it indicates SPD, capital D. Okay, and the notation is X, which is coming from L value, and subscript is twice S plus 1. S is capital S here, and superscript is J value. Okay, so for J equals to 1, L equals to 1, that means it gives P, capital P is here, and superscript is twice S plus 1. S equals to 0 here, so 0 into 2 is 0 plus 1, so that's why 1 only here, and subscript is J value, so J is 1 here. So for similar way we can find the spectroscopic notation corresponding this LS and J value. Okay, so this will be the probable state corresponding L, small l1 equals to 2 and small l2 equals to 1. Okay, now next question. Next question, F. Okay, so find the magnetic dipole moment of an electron in this state. Okay, so X equals to D, that means D means what will be the value of L, SPD, that means it will be 2, and twice S plus 1 equals to 2 is here, so S will be what, half. Okay, and this value is J value, that is 3 by 2. Okay, so we have to find the dipole moment. Okay, so here this is the state, and we know that dipole moment is defined as Gj mu b times root over j plus j j into j plus 1. Okay, so this mu j is called Landesi factor, and mu is the Bohr magneton. We have to find the value of mu here. Okay, so the Landesi factor is defined as 1 plus j into j plus 1 plus s into s plus 1 minus l into l minus 1 divided by twice into j plus 1. Okay, that is 1 plus j into j plus 1 plus s into s plus 1 minus l into l plus 1 divided by twice of j into j plus 1. Okay, so here this l is here 2. Okay, l is 2, j is 3 by 2, and s is half. Okay, after substituting this value we get Gj, that is the Landesi factor, uh, is 0.8. Okay, so we know that mu is defined as Gj mu b times root over j into j plus 1. After substituting this value we get the value of mu, where mu b is the Bohr magneton with this. So if we find the if we want to find the mu value in terms of mu b Bohr magneton, then the value will be 1 point approx 1.5 times mu b. Okay, So where mu b is the Bohr magneton. Okay, now next one, find the term symbol of the ground state of scandium. Atomic number is 21. So we need to find the term symbol of the ground state. Okay, now what is the term symbol of the ground state? Okay, now for scandium, what will be the electronic structure? Okay, if we uh, focus on the uh, outer orbit, then we get this scandium is 21, that is 18 plus 3. Okay, where 18 corresponding to argon. Okay, that is the noble gas. And next 3d is 3d1 and 4s1. Okay, 3d1 4s1. So valence orbital will be 3d, that is 3d1. This is the valence. So valence is what? Valence is here 1. Okay, scandium valence is what? So valence orbit will be 3d1. Okay. So corresponding L is D, L is 2, S is twice S plus 1, that is twice S plus 1, that is half, I think, and one single electron, and J equals to this, that is L plus S, L minus S2, L plus S. So this is J value. So what will be the ground state? Now ground state will be corresponding this minimum J value, that is 3 by 2. So ground state will be D, that is L equals to 2 means D, twice S plus 1, that will be 2, and J value is 3 by 2. Okay, so this is the term symbol of ground state of scandium. Okay.